so much for joining us this morning. I know it's quite early. My name is Shannon Brown. I'm the Knowledge Mobilization Manager for the Office of Research Agri-Food Partnership, and I'm very excited to welcome you to today's Pathways to Commercialization, Spotlighting Successes of the Griffin's Lair Program event. Griffin's Lair is a pretty unique program funded by OMAFRA and the University of Guelph, and it's designed to support the commercialization of research findings. And so today we've got a pretty great lineup of folks that are here to share the stories of their research and the process of moving their innovations out of the academic space and beyond. And so before we get started, I do have some general housekeeping that I just want to cover. I think it's pretty standard. I think we're all fairly used to it, but I would just ask that you keep your mic muted throughout the sessions. We're going to be using the chat to ask questions throughout, so please feel free if you have any questions to submit them throughout the presenters' presentations. And we'll be asking them to each of the speakers after they present. You'll also have the opportunity to come off your mic and ask questions if you so choose. So as we're learning today, I want us to take a pause before we start. I think it's important that we recognize the significance of the people that have lived across the rural areas of Ontario for a millennia. And so while we listen to today's presentations about moving forward with product development and commercialization, we also have the opportunity to consider all of those people who have lived on this land and sustained it in abundance, as well as the Indigenous people who are alive today, and for those who will come in the future, while considering our own relationship with the rural areas around us. We acknowledge that the University of Guelph resides on the ancestral and treaty lands of several Indigenous peoples, including the Attawandaron people and the Mississaugas of the Credit, and we recognize and honor our Anishinaabe, Haudenosaunee, and Métis neighbors. As we come together in a distant fashion, you may also be located in a different part of Ontario or across the country, and I do encourage you to seek out the Indigenous history of the area that you're living and working in. So to get us started today, I do have the absolute pleasure of turning us over to Luke Gartner, a Senior Research Advisor for the Research and Innovation Branch of OMAFRA, as well as Jessica Bowes, the Assistant Vice President, Research, Innovation, and Knowledge Mobilization at the University of Guelph, for our opening remarks. So Luke, I will turn it over to you first. The virtual floor is all yours.
Thank you. Good morning. I'm a last-minute substitution for Jen Liptrot, our director. Welcome. Today's event is a knowledge-sharing session that highlights Alliance-funded commercialization activities from the Griffin's Lair program. This unique program involves transferring research and innovations into marketplace in order to benefit the lives of the people of Ontario by enhancing business productivity and creating jobs. It's very important to support the work of this program as it aims to take research and use it to create new products, attract private sector funding, create jobs, and improve competitiveness of Ontario. We're happy to have the opportunity to share this Pathways to Commercialization event virtually, which enables us to broaden who can attend. For the past 4 years, I've had the pleasure of having some involvement with the Research Innovation Office and their program, and I've been constantly impressed with the creativity and drive of everyone involved. I'm looking forward to hearing from the researchers and the partners today to learn the progress they're making and endeavors and the insights they're gaining. Wish you all the best for this event today, and thank you for your work and taking the time to present today.
Thank you so much, Luke. Jessica, I will turn it over to you.
Thanks, Shannon. Good morning, everyone. On behalf of the University of Guelph, I'm pleased to welcome you to today's Pathways to Commercialization event, which will profile projects funded under the Ontario Agri-Food Innovation Alliance's Griffin's Lair program, as you've just heard. This event is an opportunity to hear from academics and industry partners about the pathway from research to product commercialization. Thanks, Luke, for opening the event today, and thank you to OMAFRA for collaborating to bring today's session to fruition. At the University of Guelph, we share a commitment to improve life. We're proud to work with the Ontario Ministry of Agriculture, Food and Rural Affairs through the Ontario Agri-Food Innovation Alliance to improve the lives of farmers, members of rural communities, and all Ontarians by supporting research that fuels innovation and economic development, all of which to support a vibrant agri-food sector here in Ontario and across Canada. The Griffin's Lair program provides a unique opportunity to move innovative research beyond the academic space. Through this program, which is expertly administered by our team in the Research Innovation Office, University of Guelph researchers turn their ideas into marketable products or services that make Ontario more competitive. The Griffin's Lair program fosters innovation, connects researchers with industry, and helps remove barriers that slow down commercialization, all to help accelerate the movement of technologies and innovations to market. During today's event, we will hear from University of Guelph researchers and their industry partners about their work to translate research into new products that add value to the economy. We will also hear about the vital role the Griffin's Lair program plays in facilitating this process. The innovations on today's agenda span a wide range of areas, topics, and sectors, but they share common goals of making the lives of farmers easier, enhancing the health, well-being, and productivity of those involved in the agri-food and rural sectors, and providing opportunities for economic recovery. We're excited to have you join us today to hear how the Ontario Agri-Food Innovation Alliance paves the pathway from research to product commercialization through the Griffin's Lair program. Enjoy.
Thank you so much to both of you. That's really excellent. And I hope, everyone is sort of where I'm at in terms of excitement to get us started. And so in order to really show you how excited I am about where we're going right now, I'm going to open us up to our first session. So thank you again to Luke and Jessica. And to get us started off, I'm going to turn us over to our first set of speakers. Perfect, just as they get their presentations loaded up there. So to get started off, we have Dr. George, George, I'm so sorry, George Funder-Merva and Richard Price to talk about craft brewing in Ontario. So George is a yeast molecular biologist whose research group studies the genetic, molecular, and metabolic adaptations and responses of these fascinating microbes to different environments. They apply this information to address concerns or provide alternative strategies in the fermentation industry. After an initial focus on wine research, George became fascinated by the growth, development, and continued innovation associated with the craft beer and cider industries, where his research group currently focuses their attention. Richard Price is the co-founder of Escarpment Labs and is an active brewing scientist and longtime home brewer. At Escarpment, Richard's focus is on translating new research into exciting products and knowledge for brewers. Richard loves to help the Escarpment team and the brewers they work with to solve problems, overcome challenges, and unlock efficiencies. One day, Richard will write a manifesto on Brettanomyces, and we love to see it. So George, I will turn it over to you to get us started.
Okay, thank you. I'm not muted, am I? Thank you, Shannon, very much for that introduction. As Shannon mentioned, the focus of our research is to understand how yeast respond to their environments. That means the nutrients that they encounter, and also how they respond to their stresses. And to start our morning off, we're going to talk about brewing and beer, first off at 9 in the morning. So this is an exciting time for us. So one of the things that we have to keep in mind when we think about craft beer brewing and where we apply our research is that it's a fairly simple process when you think about a beer brewing. It's a substrate wort, which is basically a product of cereals and grains that is fermented by yeast, of which there are many different kinds. The wort gets seeded by the yeast, and ultimately you see a range of different products that can be produced. So there are some diversity that is present here. In craft brewing, the yeast is provided as an active yeast slurry, not as a dried yeast, to brewers by yeast producers, and ultimately this is then the product that's sold to ultimately make these beers in the craft industry. However, there's also a need for innovation. If I can get my there's a increasing demand from the consumer to increase the diversity of the products that we actually do sell to them. And there's also a need for different breweries to set themselves apart in the market space from one another, both for local competition and also from international competition. So there's a need to drive this innovation. Where we come into play is to actually see whether or not we can increase the diversity of the different kinds of beer yeast that's being used to ultimately facilitate the production of beer. Not all yeasts are created equally, and consequently they all have different characteristics that they impart on the beer ultimately. To make this process happen, my lab collaborated established a collaboration a long while ago with the Escarpment Labs since the inception. You'll hear from Richard Priest a little bit later on. And we collaborated along with a few other craft breweries initially. It was Royal City and Wellington here in Guelph. We still get our award from Wellington. But since our list of collaborators has grown significantly, too many to list here, the focus was to increase the product diversity that we have for craft beer in Ontario. That was established, and now Escarpment actually provides yeast to companies or to breweries nationally and internationally. So we set up about establishing or creating a more diverse product range by looking for Ontario isolated yeast that could be used in product in beer production, thereby establishing some kind of a regional beer that can be made with a local yeast that would give the local beer producers an advantage in beer production. So we wrote a grant to Griffin Clare that was soon followed by an Alliance Tier 1 grant to support the isolation of different kinds of yeast, both from Ontario, which we normally call beer, wild yeast, and Brettanomyces-based yeast that are not usually used in beer production, only for a specific style of beer. And we wanted to see whether or not we can identify yeast that could be used, novel yeast that could be used in beer fermentation. So we set about isolating samples to purity from different niches in Ontario. We isolated them to purity and banked them in storage. We tested them in initial lab screens, fermentations that's done in my lab, and then we monitor how these fermentations are actually done. We look at how well they do ferment wort. We look at what the carbon metabolism is, how do they consume the different wort sugars and make ethanol, and ultimately what flavors they impart on the yeast. Now on the beer, on the final product, and then we pick a handful of strains that we think are feasible for further production of commercial scale beer, and we put them through a pilot scale testing. So with this initial funding that we got from OMAFRA, from the Alliance program, we were able to establish this pipeline for screening yeast. And as you will see later on, we use this pipeline for screening all different kinds of yeast or yeast progeny that we want to test for commercial application. Ultimately, we select yeast that are feasible. It's at this stage that we provide all this information to Escarpment, to a collaborator, and ultimately they then go and apply this knowledge, as Shannon referred to in the introduction. They go and apply this knowledge and actually make this happen at a commercial level. And so consequently, we've identified with these initial 2 grants, we've identified a couple of yeast strains, both wild yeast and Saccharomyces yeast, that can impart unique flavors and they can impart a regional quality for beer production. And these are all these products have been sold locally or has been sold by Escarpment at this stage. And Richard will elaborate on this when he speaks to us a little bit later on. The second thing I wanted to mention to you guys, the second topic I want to touch upon is basically stress tolerant yeasts. So we know that when we think about ale production, typically the yeast like to ferment in a specific temperature range, 20 to 22 degrees Celsius. And there are a variety of different fermentation stresses like high alcohol and those kind of things that the yeast doesn't necessarily like. So what we were thinking about, if we can find stress tolerant yeast that can actually help us to produce ales more effectively with a different kind of profile to them. So it turns out that in Western Norway, there are Norwegian farmhouse ale producers that have been using cultures of yeast strains for centuries within their locales in West Norway. And they have a unique system in which they do fermentations at a really high temperature and they select for fast fermentation. And this was a really interesting concept. And consequently, Escarpment got a couple of these strains and we thought, okay, well, let's test them. So we isolated these strains to purity. Typically, these are mixed cultures. We isolated them to purity, and we've got about, Richard can correct me, but we've got north of 300 of these strains now. We tested a few of them in our pipeline, like we mentioned before, and we've isolated quite a few of these Kveik yeasts, as they are called. These are just a local name for beer yeasts. We've isolated a couple of these Kveik yeasts that are phenomenal in beer production. They can ferment warm, so anything up to 42 degrees Celsius, and make a really decent ale. They can make beer very fast. They can make a beer in 2 days if you want. And they also have unique flavor profiles that are different from what we typically see in our production. So we've marketed some of these strains have already gone to market, and Richard will expand on this a little bit, and also then the kind of productivity or kind of exposure that we've seen with these strains. This has really captured the imagination of the alcoholic fermentation industry, and there's a lot of interest in this specific product, which we are developing further now. So that's pretty much what we've done in the last couple of years with Griffin's Lair and also with the Alliance program. We've been fortunate to have a couple of Griffin Lair grants. So we spoke about the ones that are bolded here. There's another one that Richard referred to that I didn't mention here for time constraints, talking about sour beer production. And then there are two currently active Griffin Lairs that we're super excited about of breeding stress-tolerant yeasts. And then also one that became active yesterday in making novel Ontario-based lager yeast. So these are all things that are in the pipeline that we will be testing in the next year or two. So what did we use the funding for then? What was the critical components of this funding? And so it helped us to actually establish the screening pipeline that I mentioned before. That is really critical. It helped us to take a variety of different microbial or yeast products to market already. And it also increased the profile of Escarpment as yeast scientists. And this is really important because they're seen as experts in Brett and in Kveik fermentations. And consequently, they are internationally renowned from this area, in this area. And this has really been important because that leads into the second component. Oh boy, I'm struggling to change my slides here. This leads into the second the point that I want to touch on that was critical, and this is the development of customer confidence. So the second point here is that the research and development that Escarpment has been involved with through our lab that participated to that to some extent is that they've developed a trust with the local consumers and also international consumers. And consequently, there's a lot of trust in their products and how they support their products. That's been important. This has also led to a rapid uptake of innovation that comes out of Escarpment. From the time of discovery that we have a product that's been deemed feasible for testing. Once it goes through our pipeline, it can take less than a month to actually have commercial beer made by that product. So the uptake is very quick. And these products are really important or has captured the attention of many people, and consequently the company is growing really fast with increasing demands. The last thing that I wanted to touch on is the future innovation. We are now moving into breeding yeasts with some of the work that we found, especially with the stress-tolerant yeast. We're breeding some of those characteristics or trying to breed some of those characteristics into new novel yeast that would expand product diversity and also processing efficiency. That's the first thing. The second thing is to see whether or not we can do some predictive modeling of fermentations by using omics-based approaches to predict how certain yeast would function within a fermentation. And through the Lair and through the Alliance Tier 1 monies that we've gotten and the results that we've gained from that, we were able to leverage funds to actually support this last point, which is currently an active research process in our project in our lab. And the last thing I was asked to comment on is how to move R&D to commercialization. I've got 2 points that I just want to briefly touch upon. The first thing is, when it comes to the smaller business sectors, it's really important for them to get their hands on research dollars. It's difficult, and Richard will attest to this, it's difficult for them to set aside $20,000 for an R&D project. If you're growing your company, you need to hire people. So it's better support mechanisms for them would be important. And when it comes to Alliance Tier 1 program, if we can have some changes in the research priorities by AMAFRA so that there's actually designated wording for beverage research, that would be awesome. Currently, there's very little in that regard. That's all I have to say. I don't know how much I've gone over time. I want to thank the people that has actually been involved with these specific things that I spoke about today. And so this was mainly funded by Alliance. We've collaborated with Escarpment, and then the people that worked on this was Richard. He came out of my lab as a master student that spearheaded a lot of the Kveik research. and also the Brettanomyces stuff. This was later taken over by Caroline Tirawa, who's a phenomenal researcher and a technician in my lab, and Barrett Foster and Jordan Hofstra that contributed to this work as well. That's all I have to say, and I can take questions, or we can move on.
Okay, we don't actually have any questions quite yet, but
Okay.
I'm going to invite us to roll right into Richard's presentation,
Okay.
and we'll take questions at the end.
Awesome.
Hey, how's it going? Just letting my PowerPoint load here. I just have a few slides, so I won't be taking too long, but I just wanted to share some examples sort of on the other side of this, in terms of how these projects have impacted our yeast company and ultimately impacted brewers out there in the wild who are making beer and selling it to craft beer consumers in Canada. Which is ultimately, that's where all this is going, right? We're doing all this research, but at the end of the day, it does have a pretty tangible end use as well, which is, I think, pretty exciting. So I just wanted to show a few examples, just sort of going back through the history of collaborating on these Layer and Alliance funded projects with George and his lab. Because I think there's a lot of really cool stories in here. So, and I think George hit on a lot of the reasons why this is important for us. As a small business, a startup that basically came out of the U of G ecosystem in 2015, one of the big challenges for us was building trust, right? We were coming up against these established yeast companies from the States that have been around for 10, 20 years, 15 years. And, ultimately they had already done a lot of work to build trust and make sure that, customers knew what their products were, believed in them. And it was really, really, really hard to win brewers over from these existing companies. Why should I order from this scrappy new yeast company in Ontario? And one of the ways that we decided that we were going to prove ourselves was through investing in research and making sure that, we're not only competing in terms of producing and sharing research for the beer industry, but we're actually winning. We want to be the best at this. And I think we're, on that path, and that's very exciting. So just going back into history, this is kind of one of the first examples was this project to isolate yeast strains. And that's also where we, wild yeast strains, where we also initially set up this yeast screening pipeline that we're still using and still running lots of data through, and still resulting in new products. So this was the first example of isolating a yeast totally from the wild. And this is maybe not the largest commercial success for us, but it was an awesome story. It got us in front of a lot of people, seeing the story of this yeast company going out and getting yeast from the wild and collaborating with the local breweries like Royal City and Wellington, and kind of putting this story about what yeast can do in beer and what kind of flavors it can create into the forefront. So I think the support of Griffin's Lair for that project was instrumental in, helping to, even just helping to promote the story of why yeast matters in beer, and allow us to start to do some more exciting things. So that led to this Brettanomyces based beer project, which is also very, very helpful, as George mentioned. And we do have a global reputation in this part of brewing at this point. We sell a lot of very boring yeasts in Canada because we're the easiest place to get these yeasts. But now that we sell internationally, I will say these are our most popular products internationally because we're known for these things. So if you look at the brewers that are buying yeast from us in the US or in Europe, they're looking for this funky stuff, this kind of weird yeast options, because this is where we've carved out our name internationally. And this is through a lot of this research that's been funded through these Alliance grants, and this has been super critical. We wouldn't have been able to share as much or create as much knowledge without them. So, we have a lot of brewers that are creating products based around this research. And then I think the most successful story thus far has been the Kvike, as George talked about, these surprisingly awesome Norwegian yeasts that, we're very fortunate that there was some pretty early support to fund research on these. We were able to get funding to research Kvike and publish about it before the Norwegians were, which is pretty exciting. And this has been a big story. There's been a lot of interest in this yeast, not just in brewing, but also in distilling and other fermentation industries. Of any of the things that we've talked about, this is the one that's really hit the mainstream the hardest, to the point where, there's even a story that talked about Kvike in the New York Times, right? This is mainstream media, beyond even the scientific publications. So that's really exciting. They didn't specifically cite our research, but they talked about the results. So, we'll take that. That's still exciting. And then, so one that George didn't mention that's also, I think, very impactful was this sour beer production grant as well. And especially in the last 2 years, something that we've seen, beyond the completion of this project, the last 2 years, we've seen sour beer popularity explode. And having done this Lair funded research to optimize our products to help brewers to make sour beers has been instrumental in our success in capturing that growth. This product, specifically Lactobacillus Blend 2.0, we launched that at the start of 2019. And, as of this year, it's now our number 3 top selling product. So this just highlights the impact of early investment in a research idea and also having a really good pipeline or business structure to turn those ideas into products relatively rapidly. And we have that ability in craft beer. The brewers are willing to experiment. We have a really good pipeline, as you've seen, to get these products to market. So we can kind of combine those two things, and we can move really quickly, turning research into new products and ultimately new flavors and new opportunities for the consumers. So I think that's it for me.
That's wonderful. Thank you so much to both of you. It's really interesting and I think really relevant and something that I think a lot of people are very interested in. So I'm going to open it up to our questions. So we've got a question in the chat, and I will also invite, if anyone is more comfortable, if you want to raise your hand and ask a question off mute, please feel free, but also please feel free to drop any other questions in the chat that you might have. So we've got a question from Donovan. Very interesting work. Agreed, Donovan. With the growing demand in local products, has there been any considerations for how yeast performance can be optimized for locally grown hop cultivars?
Richard, who do you want? Do you want me to go
Yeah,
first?
I can take it if you want. It's up to you.
Yeah, sure.
Okay. Yeah, that's a great question. I will say that is a question that would require some research dollars. There has been some research conducted on the local hop side, including impact of flavor and what makes Ontario grown hops different from hops that are grown in some of the major hop growing regions, like, for example, the Pacific Northwest. And that's been promising. There was a great sensory study out of Durham College that showed some really interesting potential. And of course, we're doing research on the yeast side, and the yeast is also key to unlocking and transforming some of those flavors in the hops. So I think it would be a fantastic project to combine those two things and, collaborate with the Ontario hop growers to understand, what is the right combination of hop cultivars and yeasts to maximize the flavors for the brewers. But we don't know the answer yet.
Yeah, I can maybe add to that a little bit, in that consistency in hop production in Ontario would be essential for growing that business, which is currently a problem, or it was 2 years ago. It might have changed. But definitely I can echo Richard here in that we would need some significant research dollars. There are people at Guelph that are interested in pursuing this, just as of late, and I know that they're putting in applications for national programs, but for provincial programs, it would be really interesting to have hops, for example, show up in research priorities for tier 1 kind of funding. And we can screen a lot of yeast that would be impactful. Absolutely. Good question.
That's great. Thank you so much to both of you. We've got one more question that came in. Do you know how the Ontario craft beverage industry compares to other provinces in popularity, innovation, et cetera? From Allison. Thank you, Allison, for your question.
I can take that. In terms of market share, Ontario is pretty middle of the pack. That's not necessarily a bad thing. To me, it suggests that there actually is a lot of opportunity for growth in Ontario craft beer, because we're not at, like, for example, if you look at BC, it's closer to 25% market share of craft beer versus not craft beer. If you look at Oregon, it's like 50%. Those are saturated markets. It becomes a lot harder to succeed as a new craft brewery in that market. If you're in Ontario and we're, I don't know, 12, 13% market share, there's actually a lot of opportunity for, smart craft breweries to continue to grow, and, continue to effectively, steal some volume from the big names. So I think that's actually a good thing. But, I would love to see craft beer continue to gain in popularity. In terms of innovation, I think, that's a little bit harder, I think, to quantify, but I do think that because of some of this kind of support, we are ahead of the pack. It's, I would say, less common in a lot of places to see support for beer research specifically, as part of, an agricultural research mandate like OMAFRA. I think it's really, we have a competitive advantage because we have access to some of this, kind of research funding that can ultimately drive innovation. And we also have a nice community of, not only the brewers, but also some of the support side, like Escarpment Labs, but then also the other ingredient producers like malt and hop companies that are, very much interested in kind of pushing the dialogue and supporting innovation as well.
Okay. That's awesome. Thank you so much, Richard. Thank you to George. I don't see any other questions. I will say, if anyone has any other questions that come up, please feel free to submit them, and we will collect them and probably tap on our presenters afterwards to answer any questions that come up and don't have a chance to get answered at the moment. That's great. Thank you so much to both of you. That was really great to hear about. And so I'm going to introduce our next set of speakers. We've got Wael Ahmed and Paul Subject to talk about the technology being used in aquaculture and greenhouses. So Wael is a professor at the University of Guelph with over 25 years of academic and industrial experience. He's working in the thermofluids area with a particular interest in multi-phase flow analysis of energy, water, and food systems. Wael is an expert in designing multi-phase flow systems and is a member of the Ontario Society of Professional Engineers. His designs were primarily used in nuclear, oil, and gas and food industries. He's also the founder and CTO of Flownergia Inc., which is commercializing high-efficiency flow pumps for water, energy, and food applications. Paul Subject is a seasoned senior executive, entrepreneur, private equity, and angel investor in a number of industrial technologies in Ontario, as well as president of Stanmec Technologies Incorporated, an engineering equipment company located in Burlington, Ontario. Paul mentors the CEOs of a number of industrial technology companies throughout the Oakville, Burlington, and Hamilton region, and provides strategic advice and consulting services through Enhanced Performance Inc. Paul is a graduate of Ryerson Polytechnical Institute and is a member of the Canadian Society for Senior Engineers. He spent the last 42 years in senior management and senior technical roles in both large and small industrial enterprises, including companies such as General Motors and Canadian Occidental Petroleum. Paul currently lives in Burlington, is a founding board member of the Angel One Network, and sits on a number of boards of private companies and selected community organizations. So without further ado, I will turn it over to Wael and Paul to take us away.
Okay, thanks so much, Shannon, for the introduction. Let me share the presentation here. Yeah, good morning, everyone. So I will take a different approach for my presentation, as I'm coming a little bit away from the agriculture industry and try to get my research aligned with the University of Guelph kind of theme for being a food university. And today I'm going to talk about efficient pumping technology for food application. So before I start my pathway to commercialization, I would like to share with you my pathway for innovation. So as Shannon mentioned in the bio here, I started back in 2001 designing system for aero engines. And then when I joined nuclear power generation at Atomic Energy of Canada, I developed technology for handling radioactive materials that is being used by Bruce Power and OPG for nuclear application. And then moved to an oil and gas industry, which is I continue to work on pumping, like, oil and gas, a mixture in a pipeline for oil transportation. And when I joined University of Guelph, I kind of like, switched to my kind of area of expertise into moving into the food and agriculture systems. So through all this journey, I start learning about like innovation in terms of like, basically starting with the problem you're trying to solve in the world. So looking into the International Institute of Applied System Analysis, and looking at the energy global usage projection over the years. So the International Institute of Applied System Analysis indicated that, like, by 2030, we're talking about like 40% of the energy usage in the world can be avoided if we improve system efficiency in many mechanical engineering systems. So when I designed my multi-phase flow and energy lab, basically, I was focusing more into improving knowledge by providing solutions to many industrial problems, and also providing technology that can basically make system much more efficient, which has a huge potential in the agriculture and food industry. So multi-phase flow lab is basically like, it's a lab that is basically dealing with the interaction between phases like gas, liquid, and solids, when you have a very complex interaction between these components. And it is in wide range of application in the food and energy sector. So we look into how can we define the problem, and how can we use our knowledge in the fluid mechanics in order to define this problem, and try to maybe design system that is better efficient in terms of energy, as well as, can provide additional benefit to the production or the process that you are actually targeting in these applications. So the technology that I'm talking about today is a new technology of airlift pump. And this airlift pump technology is applied in the first phase of my research into aquaculture industry. And for this case is like basically looking into traditional facility and trying to minimize the energy in this system. So our technology is basically combining two systems of used in aquaculture farms and fish farms for aeration and water circulations. So we are actually using our technology in order to basically combine these two systems into one system that has much better efficiency. The pump that we're talking about here, it doesn't have any moving parts. It's all driven by air. It has a low initial cost as a farmer can adapt with return on investment about like, a year to a year and a half. We have a very low maintenance cost, and also we can use the pump for water circulation and also improve water quality. These pumps, as I mentioned in the beginning, have been developed over years for different type of application, and we were able to modify and develop this pump for the aquaculture industry. So when I look at my pathway for commercialization, it's like, it's all starts by kind of, connecting with the Research Innovation Office back in 2014 when I joined University of Guelph. And I owe a lot of debt to David Hobson, who's basically working on as a knowledge mobilization manager at that time. And we're looking at like, how can we use this technology in the food application? So all things started with a market survey, and I'm basically looking into the best fit for this technology in the use of and the food industry. In order to do this, basically, we had to go over some technology validation, and the technology validation we're talking about here is like basically require lots of resources in order to develop these process. So starting by developing the research team and the resources, and one of the biggest resources I have over the last 5 years is like the graphene layer support, working with team of the engineering students to do a lot of field testing, but as well as also working with many industrial partners to really look into what is their system performance and how can we improve the system performance in terms of making those systems are more efficient and higher production as well. The last part here is basically choosing the right commercialization path, which is was a great help of the the Guelph Accelerator Program, as well as the School of Business, and also looking for what will be the right approach to basically start this commercialization, and also looking at business partners and investor in this process. So through about 5 years of graphene layer funding, I have got 4 projects to work on, starting from technology validation back in 2015 to field testing and product optimizations, as well as product development for different applications. And the next product will be looking into how can we use these pumping technology for other application and other markets, such as greenhouses, hydroponic and aquaponic, food waste, and wastewater applications. So what we have done over the last 5 years have demonstrated a huge impact on many farmers' usage across Ontario. So we have demonstrated the technology to several farmers across Ontario, as well as Prince Edward Islands at Aquabounty. We developed the technology and we demonstrated at multiple exhibition show, and the technology recognized as one of the design that can change how the world in moving fluids and multi-phase fluids in many food systems, and recently recognized as one of the clean tech technology that can be watched for in 2019. So we were able to really demonstrate the the advantage of this technology to be used for aquaculture industry by reducing the energy by 50 to 70% and improving irrigation by about 40%. So by that time we have started a company called Flonergia, but I would like to recognize the talent engineering research team that I have been working with over the last 5 years, developing all these tests and design modification in order to be able to finalize our product development stage. And I would like to ask Paul Subject here to jump in and talk about the broader impact of our technology on the aquaculture and other industry around the world.
Thank you, Will. Hopefully you can all see this. Just like to talk a little bit about the Flonergia story, and talk a little bit more in detail about our products. And I have to profess I'm in love with our pumps. I love our business, and quite frankly, the progress we have made so far would not have been possible without the cooperation and collaboration with the Research Innovation Office, and in no small part to the work that was done by WAIL with the various Griffin's Layer projects. So our pumps, just to talk about our pumps, are offered in 6 different sizes, up to 8 inches. Our smaller pumps, our 1/2 inch, 1 inch, and 2 inch pumps, are printed in 3D in food grade polymer. Our large pumps, 4, 6, and 8, are fabricated from PVC, and all our pumps are manufactured here in Canada. I'll talk a little bit about our market, go-to-market rollout strategy, because I want to get the business part of this finished first before I talk about my remarks about how to move forward with innovation. Currently, we have customers around the world in Canada, Chile, Costa Rica, India, and the value of our sales pipeline is greater than about $2 million. And it all started with field trials, as Will talked about earlier, in 2017 and 2018. And in 2019 and 2020, we decided to finalize our manufacturing strategy and build sales channels with distributors in Canada and India. And this year, we've added 2 more distributors, and we're currently developing distribution in Australia, Germany, Southeast Asia, with continued global expansion, new product introduction, and market diversification. And I just want to talk about what our market entry strategy is a little, to give a little bit of flavor for everyone so they understand how we introduce our technology into the markets. We first start with product trials and direct sales to key customers. And those are customers in many, many different markets. As Will said, we initially started in the aquaculture market, but we're now venturing into the water and wastewater marketplaces, as well as greenhouses, aquaculture, aquaponics, and hydroponics. And in some cases, we're willing to license our technology across various markets where the opportunity presents itself. But our primary driver is to develop partnerships with consultants, engineers, system designers, and distributors around the world. So the Flownergia story is pretty simple, right? I became involved with Flownergia shortly after it was incorporated in 2016. We're so fortunate to develop a very collaborative relationship with the Research Innovation Office, which led to a license agreement for the base technology for our FlowMove airlift pumps. Our pumps are currently being sold in aquaculture, agriculture, wastewater, and related markets around the world. A true success story. My role, I'm CEO. I'm responsible for the business of the company, including the total commercialization of product. And with my partner, Well, and since the inception of the business, we finalized our design, developed and implemented our manufacturing strategy, developed and implemented our sales strategy, and we're building our global brand. Now, what's the intersection between research and reality? What I'd like to talk about in terms of commercialization. You know, you have to develop a unique perspective on how to develop our product from pure industrial research. Dr. Ahmed and I share the same point of view, developing research-based products that can be used in the real world. And this is one of our fundamental drivers for Flownergia. And we are continuing a collaborative research effort with the U of G to further expand our basic and applied research in this technology area. The business considerations that we take into account is we've evaluated each of these considerations during our business planning process, which started at the very beginning of Flownergia. That's how Will and I met. He asked me to give him an opinion on how to develop a business plan for the product that he was developing. And of course, we looked at the risks, barriers, competition, profitability, our time to positive cash flow, and the specialized corporate skills that we would need in order to implement a successful business plan. And funding opportunities, you know, these became available through various programs for university research. And quite frankly, they're invaluable for companies with viable commercial opportunities. And we've been very fortunate because we've been able to leverage the past work that has been completed using all of these various funding sources that Will talked about. And they're especially effective, and this is one of my key points, with targeted commercial applications. And we've heard a little talk about the opportunity in the beer business. And of course, our technology is aimed towards the actual transportation of fluids, but real commercial opportunities result because of tangible products that can be commercialized. So I have some suggestions, of course, about how to improve the interface between research and industry. And of course, that's to make funding programs more flexible, to entice seasoned entrepreneurs like myself to be the first receptors of these de-risk technologies. Additionally, we need to develop programs that help fund these entrepreneurs to start companies to bring new technologies to market, and stimulate more people like me to understand, who understand adoption and risk management, to get involved and to get a new product launched. Qualifiers for investment, of course, we need to work with innovators that are easy to work with and understand their strengths. Whale and I have a true partnership in our business, and it's because our strengths and weaknesses complement each other. An innovation that's easy for the buyer to understand, that has a real market that's been addressed and identified, that solves a real and recognized commercial problem, where the bulk of the product development has been completed, where the innovation has been tested at least as a prototype so that an existing sample exists in the real world, and an innovation that is qualified as a result of an extensive potential market assessment. All of these things make for a very viable and real investment. That's the end of my presentation, and love to take any questions.
Excellent. Thank you so much to both of you for sharing that incredibly interesting story. And also, nope, that's all I got. Very interesting story. I'm looking at the chat and I don't see any questions quite yet. So I will invite anyone to take a moment to drop a question in the chat, or if you have any questions, to please go ahead and raise your hand and we can take you off mute and you can ask your questions directly. We'll also give us a second because I know typing takes time.
Good morning, Paul and Wal. It's Thomas here. So have you been involved with IRAP or MITEX or other funding agency to leverage your funding outside of the Alliance programs?
Will, do you want to answer that?
Yeah, I mean, like, it's thanks, Thomas, for the question. Like, at that stage, like, in our technology that we already tested in the fields, we got, like, customer asking for buying the technology back in 2017. So we didn't even have time to really test it more in the markets, as the customer were already ready to really buy those products. So some of, like, our customer actually needed like a quick turnover for these pump to be manufactured. So we couldn't really use that much the IRAP part of this. Is also, like, the limitation of the IRAP program is asking you to have, like, a $200,000 kind of sales before you getting into the IRAP, and by the time you are doing these sales, you don't really need to do, like, more IRAP stuff. So it's kind of like, it was tricky from our end. In terms of MITEX, I guess Flownergia already put a couple of MITEX projects to University of Guelph, and we hire students to work on MITEX with Flownergia. Yeah.
Mm-hmm. Thank you.
Thank you so much, Thomas, for the question. We've got a couple of questions that came into the chat. I think we've got time probably for both of them. So from Dana McCauley, she would like to know what Flownergia technology can accomplish in the food manufacturing sector to deal with wastewater issues that are common in meat processing and dairy processing.
Huge potential. Like, we actually over the last year, we've got a lots of inquiry on our website of Flownergia for the pump used in many food applications, so, and wastewater applications. So we have been learned that our technology can be used in many industry. We're, like, basically handling mixture of solid and material type of things. So and Paul can maybe talk more a little bit on wastewater application as well.
Yeah, absolutely, and that's a great question, Dana. I guess my answer is actually to ask another question. It's really, where can we help all food processing industries, because basically our technology moves fluids, and those fluids can be loaded with a high level of solids, and that helps specifically in wastewater, but it also helps in every sub industry of wastewater, including meat processing and dairy processing, and we're exploring those issues right now as customers find out about the amazing capability of our pumps. There is really no limit where we can be applied.
Excellent. That also sounds just very exciting, and really great to hear that there's so many different applications for this. I've got one last question from Rebecca. So how important is it to have public funds available for de-risking technologies to encourage commercialization?
Wow, that's a great question. And of course, I brought that up because I think it's important that technologies be de-risked to the point where innovators and entrepreneurs are willing to invest their time and their money into technologies. And I think the answer to that is that at the, and I'll talk very technically, at the TRL7 stage, at a stage prior to commercialization, I think it's very important for funds to be used to establish commercial opportunities, market studies, and those kinds of things. And Dr. Ahmed used these market studies through the Griffin's Lair as a very effective way to determine in the beginning what the opportunities were that were in the market for what became the FlowMove pump for Flownergia. And that data was very, very important to convince me that this was actually a very viable, commercially viable opportunity. And I think those are the kinds of things that needs to continue to be funded in order to encourage future development of and commercialization.
That's excellent. So we got one more question, and looking at the time, I think we have time for it before we head into our break. So I've got a question. What is the current size of Flownergia, specifically around, I guess, employees? And what has been the growth of the company, and what would you see as sort of the next big milestone for your company as far as moving from the startup to the next stage?
Oh, that's a great question. So the company is, we basically have 4 employees in total, and we probably call us a micro company. We've grown to, this year will probably be $250,000 in sales. We have 3 very large projects that are many millions of dollars in our sales pipeline. So the next big hurdle, I think, for us, Dr. Ahmed, what do you think? $1 million in sales? That's our target?
Yeah.
Yeah. So, and we expect that in the next 18 months. We have an entire initiative around deploying our technology in solar applications where there's a very poor power grid in the aquaculture business, and we think that that's going to be a huge step for Flownergia.
Excellent. David, I see you've popped on for a hot second. I'm sure it's to jump in with something insightful, so I will indulge you in this.
No, the insightful ones are the speakers. But I do have one quick last question, which is, you guys chose to go the startup route to bring your technology to the world. That's often the toughest route to take. It's very hard, very unpredictable, lots of uncertainty. Why did you pick that path? Because you've done it so successfully. What's the critical ingredient, or what do you think made the difference that has let you achieve your success as a startup?
That's a great question, David. And I think it really has to do with the experience that the whole team has in terms of collaborating together and developing a strategic business plan where we can implement it with the resources we had available. It's a tough road to hoe as a direct startup. Ask me, I'm the guy who writes the checks, but I can tell you it's been worth every step of the way, because we realize that our end goal, quite frankly, is to annoy very large pump companies to the point where they'll end up acquiring us, and we're already well on our way to doing that. It was one of the alternative strategies that we've talked about is actually licensing our technology to pump companies, but I think we need to become big enough via the startup route to do that before we can plan our exit strategy. But that's a great question. Thank you very much, David.
Thanks, David, for jumping in with that last minute great question. And I'm looking at the time, and we are still perfectly on time. So feeling great. Thank you so much, Paul and Wael, for sharing that very interesting story. And it's great. It's really great to hear sort of where you started and where you are going and where you currently are. It's incredible. So that is it for our first session. We're going to give you a chance to get up, stretch, daydream, grab a coffee, grab a beverage of choice. We'll be back in 10 minutes, so around 10:10. We're making it really easy to remember, just 10 minutes on the 10. So please take a moment to yourselves and we will see you back shortly. So welcome back, folks. I hope that everyone had a chance to really stretch, to take a moment to yourself, to step away from a screen for a small second. And I'm going to start us off, lead us into our second session of the day with our next speaker, Michelle Oliver, who's going to be sharing her work on mobile agriculture machinery. So Michelle has a multidisciplinary background with a bachelor's and master's degree in kinesiology, as well as a master's and PhD in mechanical engineering. Michelle is a former Canadian national swimming team member and a member of the McMaster Athletics Hall of Fame, who continues to compete at the master's level. She's a professor in the School of Engineering, and her research area is in occupational biomechanics and ergonomics. She's a former holder of an NSERC University Faculty Award, as well as an Ontario Early Researcher Award and an NSERC Accelerator Supplement. She's been awarded a Guelph Wellington Women of Distinction Award in the Science, Technology, and Research category, and was a member of the team of professors and staff teaching second-year engineering students who won a University of Guelph Provost Award for Innovation in Teaching and Learning. Take it away, Michelle. We're really excited to hear about your work.
Great. All right, is that, can you see that, Shannon? Or can everyone see that?
Yep, that looks perfect.
Okay, great. Thanks very much for that really nice introduction. So yes, I'm Michelle Oliver. Just a little bit of background about me. So my research area, it sounds like someone in biomechanics should not be developing potentially products for things, but my area of research actually is in biomechanics of heavy machinery operation, so heavy mobile machinery operation. And I started out my career looking at joysticks and how we could change the way that people do work in order to reduce the incidence of repetitive strain injuries, because a lot of people who operate joysticks over a 10 and 12-hour shift end up with neck and shoulder and wrist issues. And so that led our group to design the world's first dynamic armrest that both translates and rotates with an operator's arm, so that your arm is basically always relaxed. We then moved on to looking at whole body vibration, and you encounter whole body vibration basically anytime you operate heavy machinery, particularly in off-road environments. One of the things I noticed from my work with the steel mill up in Sault Ste. Marie was that we were trying to identify an optimal seat for them to replace, to retrofit their machines, their steelmaking machines with. And one of the things we saw was that basically even high-end suspension seats don't really work. And in fact, they often, or more often than not, actually increase vibration transmission to the operator, resulting in, I guess, over long-term exposure, operators developing bad backs, bad necks, and things like that. So seeing that, a light bulb went on and I said, well, okay, why do we need to replace the entire seat? Why can't we just replace the seat pan cushion? And so that kind of led us on this current journey. And obviously, I guess active vibration control is not my area of expertise. It is, however, Dr. Marwan Hassan's, who is my co-PI on this project. In addition, when we were starting out, we had to identify the right graduate student to start to look at this project. And so we did. Mr. Alex Berry, who actually works for OMAFRA as a soil management engineer. Also on our team right now is an MASC student, Mr. Yannick Habiger, who's, I guess, full-time on this project. And then finally, Miss Megan Govers, who is she's half-time on this project and also works on looking at, I guess, a retrofit kit for autonomous tractors, or to create autonomous tractors. So just a little bit of background. Basically, you can't escape, I guess, harmful vibration or whole body vibration when you operate farm equipment. And many farmers end up, I guess, having to stop driving a tractor a lot sooner than they would have if they had a device which would reduce their whole body vibration transmission. So they also have a very high prevalence and incidence of back and neck injuries. And essentially that's because they can be spending 10 to 12 hours in their mobile field office, which is a tractor. And the controls are great for all the mechanical outputs, but there's limited technology to reduce vibration, and that which does exist is either really, really expensive or it's not effective. And so basically you can only get high-end seats often for newer vehicles. And so I don't think people want to throw out all their current machinery. They want to be able to have it last as long as they possibly can. And so our device, it basically upgrades an existing vehicle and equipment. And as you see in the blue, I guess, ellipse there, or egg shape, what we're talking about doing is just replacing that seat pan cushion right there. And so it uses active feedback and advanced materials, i.e. magnetorheological fluid, which basically senses what kind of vibration is coming into the seat pan cushion. And then it changes the material properties of the cushion in order to harmlessly attenuate the vibration. And that has to be done in real time. So it has to react almost instantaneously. It's intended to be plug and play to retrofit any existing seat and just require power from a 12-volt source. And we're pitching it at about 20% of the whole body vibration reduction system, i.e. the whole seat that you see there. So we're looking at it just being 20% of the cost. And trying to make it comparable to what you would normally pay for in a seat to replace individual bits of it. So we're pitching at about $1,000. This, if it works, or I guess if it's universally adopted, it could reduce injuries, less downtime, and improve comfort. And I guess large farming operations where you're paying significant workplace safety insurance board costs, it could help to reduce your insurance premiums because hopefully it reduces the number of injuries. Also, it's just, the person driving the tractor is going to be a heck of a lot happier and able to focus on what they should be focusing on and not their back or neck. And also, hopefully, they can, the farming population is aging. So hopefully with a better workplace environment, we can attract and sustain a much more, I guess, diverse labor market. Okay, and also obviously, I guess it goes without saying that this could result in new products and as well as manufacturing jobs. And so we've had two sequential Griffin's Lair grants. The first one allowed us to create a functional prototype, which has been field tested a little bit, but I'll explain why it's not been extensively tested. We were able to get industry feedback, and it suggested that yes, there was a market for this product. So we filed a US provisional in May 2019. We then followed that up with a market research Griffin's Lair, and that gave us, I guess, helped us out in customer discovery and market validation, and allowed us to work more closely with industry and end users. And the feedback that we got from that document is guiding further product development. And so we filed a PCT in May 2020. Through those two grants, we had one highly qualified person, and again, Mr. Alex Berry is that qualified person, and he's now, I guess, employed by OMAFRA and continues to help advance the technology. And I will say in that first project, it was, or I guess through those first 2 Griffin's Layers grants, it was critical that we, I guess, identify, we had the idea for the research piece, but we needed to identify the correct graduate student in order to be able to conduct it. And so it needed to be someone with basically a farming background, so they'd understand kind of how important it was to develop the technology. So where we're now, we've got 2 lab demonstrators for testing as well as proof of concept. We're kind of on our 3rd iteration, and we hope it will be an initial prototype with close to full functionality. So to back it up a little bit, as a result of the 2 Griffin's Layer grants, and in particular the market research one, that brought us to a contact at Hitachi in Guelph. And so they have actually given us one of their cushions out of one of their pieces of heavy equipment. And that is dictating the form factor for this 3rd prototype. So what we're doing right now, we're getting the device to fit within the cushion. And we're also figuring out the mechanism, hardware, and control system that's going to give us the correct amount of stiffness and damping at the appropriate times. And so sometimes you want the material to be very stiff, and sometimes you want it not to be stiff. The other piece is we have to worry about comfort. So we've been investigating various foams and things like that to optimize the design. So how Griffin's Layer, and I will say, I guess our project is probably the earliest in its development of any of the 4 speakers this morning. But I will say quite honestly, without Griffin's Layer funding, this project would not be continuing right now. So once that basic research was funded, so Alex Berry's MASC work, which was largely occurred I guess prior to getting the Griffin's Layer funding, after that, it was really tough to get development funding. There are very few funds around that will fund early stage commercialization. Again, the reason for that is it's seen as too applied for basic research and not far enough along for commercialization funding. Those 2 Layer grants helped us bridge that funding gap and really did allow the project to continue. So Griffin's Layer 1 enabled us to keep progressing the research. And again, as I've said before, it would not have been possible without that funding. And it facilitated HQP training of one of the co-inventors, who is now an OMAFRA engineer. And I guess I will say that over the course of Griffin's Layer 1, Alex was a project engineer in training at OMAFRA. Griffin's Layer 2 helped us understand the market and really helped us identify the multinational partner that we're starting to work with. It raised our awareness of the real market segmentation and helped us go, I guess, in a more market-aligned direction. And it for sure made us reevaluate our strategy for the ag-food market. What we found over the course of that market research is that there's a real big lack of awareness in the dangers of whole body vibration exposure in agriculture. And so I think we need to, one of our foci has to be somewhat of an education campaign to get people to understand how dangerous whole body vibration is. One of the other happy things from Griffin's Layer 2 is it helped us increase our interaction with the University of Guelph Rio office. And in particular, we started working very closely with Mr. Martin Siuk, who's one of the tech transfer officers, and he's been invaluable in helping us kind of move the project forward. How did, I guess, in general, the Griffin's Layer program help? Well, it paved the way for a successful Food from Thought commercialization grant and funding the project until September 2021. That is an actual extension on our initial deadline date, which was December 31st, 2020. And that's because some of our work needs to test our devices using human participants. And with COVID, obviously, all of that sort of things has stopped. So it was very nice that we could extend that grant. It also allowed us to identify and engage with a potential industry partner, and they have offered up approximately $30,000 in Canadian in support to allow us to test our device at the Hitachi Proving Grounds in Ohio. It also, I guess, as academics, we don't always have a good appreciation of the way industry and business works. And so it gave us, I guess, I won't say a perfect understanding of it, but it certainly gave us a good introduction to it. Our next steps, once research using human participants can start up again, we'll be testing the third prototype in the laboratory on a hexapod robot, as well as under field conditions. Again, that's with a human operator on top of the seat. We're looking obviously to secure more funding and investment. And to that end, we've got an NSERC Eye-to-Eye Phase 1 application. And we're kind of looking for more industry feedback as well as collaboration to optimize the product, and obviously continuing iterative development. Also, I guess concurrent to this, so the multinational industrial partner whom we've identified is actually Hitachi in Guelph, but that will open the door to Hitachi worldwide. And they do have, the Guelph people are primarily into, I think, mining and a little bit of construction. However, Hitachi does have ag arms, but I guess concurrent to developing the prototype for ag, we're also at the same time developing it for other industries, recognizing that different designs are required for different industries because they encounter different whole body vibration, I guess, patterns and profiles, if you will. So they do need slightly different designs. However, lessons we learn in designing for one industry certainly help to inform the prototypes designed for other industries as well. I also would like to say that probably it's probably was the most painless grant application that I've written in my academic career. Requirements are simple, form is not onerous. However, I will say it's important to seek help from Rio because the format is quite unique, and I guess to Griffin's Lair and to a smaller extent, maybe to a MAFRA grants. Again, Rio can really help with getting that application done. I think it's important to understand the research priorities for a given year to ensure that your project fits. That may be more applicable to, say, Alliance than to Griffin's Lair, but I just would say that, you know, feedback would be, as a researcher, I think it's important that you understand what they're looking for in a grant. So I guess last, where can Ontario improve their support for moving research to commercialization? I would say, and how to kind of prevent it from languishing on the shelf, the IP that is. I would say we need more early stage commercialization grants like Griffin's Lair. This would not be, development of this device would not be continuing without the support provided by the Griffin's Lair grants. I think I'll stop there. Any questions?
That's wonderful. Thank you so much, Michelle. We do have a couple of questions. But before we get into them, I just want to say, I know you said your project is sort of, I guess, quote unquote, the least far along, but I do think it is really valuable to see, you know, the pathway that it takes to get there, sort of hence the title of this event. And we've got a comment from Dana in the chat that I think sums it up much more eloquently than I can, that it is useful to understand the runway towards getting an item into market. And that it surprises a number of people to learn that, you know, these tweaks and tests take a lot of time, and that an overnight success can take around a decade. So we've got a couple of questions. I've got one from Julia. So this is very interesting, and you mentioned a little bit about the experimental process of using different materials and foams. Are there any specific materials that you found to significantly reduce the full body vibration an operator would experience? And how are the materials that you're testing different when compared to the materials used in the existing cushions used thus far?
So yeah, great question. The foams were not as far along in understanding. We're still at the I guess the comfort stage of things in terms of identifying foams. I would say that more so we've been focused on I guess the guts of the design. And one of the things we've been using is an off-the-shelf magnetoroidal damper inside it. But what we found with that is it altered the capabilities. And so there's a stiffness associated with the MR damper itself. And so we're currently investigating looking at more of a low-tech solution, more looking at, I guess, series of springs and trying to, I guess, reduce the overall amount of friction in the system. The next stage, once we get this prototype to, I guess, field testing, is to look at some comfort assessments and probably leave the device itself open and probably slot different kinds of foams and things like that, foams of different stiffnesses in order to see which one would work best well. So there's both, if the I guess to put it simply, if the foam is too squishy, it's going to allow excuse me, it's gonna bottom out too easily, and therefore vibration, it's not going to feel comfortable if you're having to sit on this for sorry sorry get a drink here. If you have to sit on it for like 12 hours a day, it's not going to be all that comfortable. So a lot of choosing the appropriate foams is going to be trial and error rather than determining actual mechanical properties of the foam. I guess the secret sauce, if you will, the ability for the device to react instantaneously is inside is more in the mechanism of the cushion rather than the foam.
That's great. And I've got one more question from Rebecca. Thank you for a very interesting presentation. Seconded. And what piece of advice would you offer to other researchers interested in developing a product for market?
Don't be afraid to bloody your forehead. you're gonna have to. I think you have to get used to rejection. You do, and just know that you. And I suspect especially Paul would say that is as an entrepreneur, that is absolutely true. So you have to be prepared for the door to get shut on you many times, but you have to keep a positive outlook and just keep trying. I also would suggest that throughout the kind of developing this project, I learned just how I'll say it, how competent our research office is, and how diverse the expertise is in the office. And don't go in thinking that you know better than they do. They know what they're doing, and I guess you need to learn to listen to their advice. And I know some of it will be hard to hear when they tell you that your idea will never fly, or the market's just not there for your product. You need to pivot to kind of change your product or change the market or something like that. So all I would say is listen to what they have to say.
That's fabulous. All right, well, thank you, Michelle. That's really great. Thank you so much for sharing your story with us so far. And I think we're all really excited to see where it goes from here. So with that, I'm going to move on to our final speaker. So our final speaker is Dr. Thomas Koch to talk about his work on stem cells in the equine industry. So Thomas is a founding member of the North American Veterinary Regenerative Medicine Association and the immediate past chair. He's also a tenured associate professor in the Department of Biomedical Sciences at the Ontario Veterinary College at the University of Guelph, where he also obtained his PhD in the area of equine stem cells. He was the first to report the presence of stem cells within the umbilical cord blood of newborn foals. And Dr. Koch's research focuses on his research focus for the past 15 years has been on how these and other stem cells can be utilized to treat joint pain and damaged joint cartilage. He's been awarded several research awards, including a special recognition Research Excellence Award from the University of Guelph and an Early Researcher Award from the Ontario Ministry of Research and Innovation. So with that, I will turn it over to you, Thomas, to tell us a bit more about your work.
So do you see my screen?
We do. I'm seeing your PowerPoint just against your background. There we go. That's perfect.
Okay, so I'll move that out of the way. So thank you, Shannon, for the kind introduction, and thank you for the opportunity to speak today. So tough acts to follow here as the last speaker. I really enjoyed the first three presentations, and I'd like to congratulate everybody on their achievements. So I'm here today to talk about our company EQCell. So the background is that stem cells have been used in horses probably for the last 15-20 years, mainly to treat tendon and ligament injuries in horses. And it started out with what we call autologous mesenchymal stem or stromal cells. And we had a faculty member, a surgeon, who were using those cells. And there was a company at the time in Canada that were providing these cells, but then it went out of business. And he really liked the results that he saw from those cells. And then he moved to a private practice in British Columbia. So because as a PhD, I was doing my PhD at the time, he asked then if I could then start to culture these cells on his behalf, since there was no other source of it. So I started doing that as a PhD student, just as a service. And we continued to do that. We were told by the university at the time that we needed to establish a company and then set up a service contract with the university to continue the work. We couldn't just put it into the general purpose account and use the money for research as we were doing. So EQCell started in 2010, and it really started out just servicing a few veterinarians for these so-called autologous cells, where a bone marrow sample is taken from the patient itself, shipped to the lab. We then grow the cells and we ship the cells back to the veterinarian about 2 to 3 weeks later. And we continue to do that, and we have cells growing in the lab actually today that will probably go out later this week or next week to a horse in British Columbia. So it provided some modest revenue for the company, but not very much. So the challenges with this is that you need to harvest a sample from the patient, ship it, wait 2 weeks, bring the horse back to the clinic, treat it again. Although it's considered kind of the gold standard and the veterinarians really like the response they get to these cells, they have started to use other products where they can, like PRP, platelet-rich plasma, where they can get a product produced on the same day, so it's more convenient. So what EQCell is doing now, what I call EQCell version 2, is we aim to produce a frozen allogeneic cell product. So allogeneic means that the cells are still from horses, but they're not from the patient itself. So that allows us in principle to develop an off-the-shelf product. But when you go from autologous to allogeneic, there's a big difference in how this is regulated. Allogeneic is considered higher risk because it's not from the patient itself. So now you're into classical drug approval landscape, whereas autologous cells, you can do pretty much what you want. So the aim is to have a frozen product that you can basically pop into a toaster like this, and then a few minutes later, it's thawed and ready for injection. So as Shannon said, we were the first to report the presence of these stem cells within the umbilical cord blood newborn foals. So it's collected at the time of foaling, and then the blood is shipped to the lab overnight. In the lab, we can then set it up in culture, and we get these what we call fibroblast-like looking cells. When you just look in the microscope, it doesn't look, it looks very static, but if you do time lapse over the weekend, you will see that these cells are dividing and moving around, stuck or adhering to the plastic of the flask. So these cells have been compared to, the smartphone, and they're able to do a lot of different things, almost like different apps. So what app categories are there? There are fundamentally two categories. One is progenitor function. So this is what most people would think of when they think stem cells. They can give rise to different types of cells and different types of tissues. So basically, cell replacement, tissue replacement strategies. So in my lab, we're interested in producing cartilage from these stem cells. And this is a sheet of cartilage that we have produced from the stem cells. The other function of stem cells is what we call a non-progenitor function. So here the cells have kind of a sentinel role. You inject them unmodified, and then they take cues from their environment, and then they change their secretome and how they interact with cells within the body. So if you have an orchestra, the stem cell would be the conductor that would then start to direct cells within the body to change their function. And one of them is immune modulation or anti-inflammatory properties, but there are many other properties, including antibacterial effects, that these cells can potentially have. So our first product is to try and use these cells to treat joint inflammation, synovitis in horses. So again, it would be a frozen allogeneic product. You can have smart shipping containers where you can control the temperature. You'll be able to put in a geofence so that when the product is 10 kilometers away from its destination, people would receive a message on their cell phone, and they can start to get the patient ready for the injection. Or veterinarians that are using it a lot can buy a lot of products and just have it in a -80 freezer ready to use. So one of the questions is obviously, are these frozen cells equally functional to cells that are not frozen? So that was part of the research that we did, and we showed that they work just as well immediately after thawing. We also did studies in live horses showing that we can inject these cells without seeing any adverse reactions. And then in a model where we induced inflammation in horses, we saw that the cells reduced the synovial fluid nucleated cell count, so they were effective against inflammation. So another product that we are interested in is frozen stem cell derived cartilage available on demand. So in human and horses, when you have a discrete local cartilage defect exceeding 4 centimeters square, it doesn't heal on its own, and it will progress to osteoarthritis if left untreated. So this is a big problem in human and horses. So in Canada, osteoarthritis and joint cartilage damage is probably costing society $33 billion a year, and 60% of osteoarthritic patients are actually of working age. So it's not just it's not an old person disease. It really affects younger people as well. So one method that actually have shown promise is to take cartilage either from a non-weight bearing area of the joint, harvest that and use that for kind of a pothole repair, or from cadavers, so allogeneic again, not from the patient itself, and that has shown clinical promise without adverse reactions. However, there's obvious supply issues as soon as you talk about sourcing cartilages from cadavers, and also quality control issues, because a non-weight bearing part of the joint, the cartilage is not as strong as the part of the cartilage that you bear weight on. It's a mechanical tissue that adapts to the mechanical loads. So we have received funding for this from Equine Guelph, OMAFRA, CHI recently, and also the Grayson Jockey Club. So what we do is in the lab, we create cartilage grown on these small membranes, and it looks white and glittering like cartilage. And it's stiff, and it looks like cartilage on histology as well. So in a few research horses, we injected these cartilage pieces into the joints, and this was one horse that unfortunately was euthanized after 3 months, unrelated to our work. We didn't intend to euthanize the horses, but it allowed us to look at the tissue after 3 months. And this, we did a biopsy sample actually before we took the picture, but there was surprisingly good tissue fill in this defect already after 3 months. And you can see this is our tissue engineered piece of cartilage sitting here partly in the defect. So that preliminary data was enough that we got CHR funding to continue this work. We're working together with the University of Alberta, which they have a method where they can vitrify cartilage. So here you have cartilage that has never been frozen and cartilage that was frozen and then thawed again. And when we do various assays on it, we actually don't see a difference between the non-frozen cartilage and the frozen cartilage. So it appears that we have a method where we can produce cartilage from stem cells. We can freeze it down for long-term storage so that it would be available to the orthopedic surgeon on demand. So the surgeons at OVC that I collaborate with is Dr. Koenig and Dr. Mark Hurtig, and here they're in the operating room implanting the cartilage that I just showed. So we've been supported with both the market assessment grant, but also the product development grant. So the product development grant, we have work ongoing together now with Professor Mike Callas at the University of Calgary to scale the production of the stem cells in bioreactors. So I showed a previous video that these are adherent cells, they stick to the plastic. So in bioreactors, we have these microcarriers that the cells then adhere to and grow on. And if we stain the cells, you can see them kind of stick to the surface of these microcarriers. So we did one publication together just in this simple stirred bioreactor. What we're working on now is together with American company PBS Biotech, where they have these vertical wheel bioreactors. So the project to date is now that we are in the 100 milliliter and 500 milliliter system, but this summer we will go to the 3-liter system, which is fully automated, and you can control everything, dissolved oxygen, pH, everything is in a controlled system with disposable material. So the role of the Alliance funding is, as you know, we say the currency of grants are publications, but the currency of private investment is really clinical data. And our access to horses through the Tier 2 program has been absolutely critical. And I've mentioned a few publications and ongoing work utilizing our access to horses through the Alliance program. For the CHR project grant, I'd also like to these are the scientific officer notes, just stating that we're working with a problem of high potential for clinical translation to human cartilage defect. And then they say the model is interesting. The horse model is well justified, and preliminary data regarding incorporation of cells into defect are encouraging. So that's the work we did in these horses through the Tier 2. And then good leveraging of other funding resources. So that's again in the budget that we have access to horses at a subsidized level. This spring, we also supported by the Grayson Jockey Club Foundation. And they also said clearly this project was regarded as one of the best recommended by the Research Advisory Committee. And I would just like to stress that this would not be possible without the access to these horses, and really show that there is potential in horses. And it's recognized, so we can now both tap into funding on the human side of things where there's a lot more money available, and as well as in equine specific funding. So I've been the beneficiary of a lot of funding through the Alliance program, one Tier 1 grant, multiple Tier 2 grants, 2 Griffon Laird programs. And as I said, it has been leveraged to a number of different funding resources. On the business side of things, being part of the Griffon Laird program and accelerator program in Guelph also allowed us to become part of the AC Jumpstart program in Waterloo. And we have now secured seed funding investment in EQCell, and EQCell in turn has been able to provide Mitacs postdocs that are now working at the University of Guelph to further the project. So the next steps for the equine synovitis project is that we're doing clinical pilot studies this year. We already approved to begin work at UC Davis at the Veterinary College in California. Our protocol is under review by the Veterinary Drug Directorate to do work at OVC. We work together with the Regenerative Medicine Institute of Ireland for GMP cell manufacturing. And then we hope next year to have GMP produced cells so we can conduct a pivotal trial next year that would lead to drug approval in Europe first, followed by North America afterwards, and then ultimately have our own GMP facility in Ontario. And we've already been talking with FedDev Ontario, and they say once we have a product approved, we would be a very good fit for funding through them. So just a note here, we are pursuing European product approval first because the horse in Europe is a minor species compared to North America. So the regulatory landscape is quite different, and it would be easier to get drug approval in Europe first and become revenue positive. The vitrified stem cell cartilage project is that we will continue with work in research horses this year. We are working with human cord blood cells right now in the lab as well as part of the project, and we'll be making cartilage from the human stem cells this year and try to vitrify that. And then we hope next year to start pilot studies in client-owned horses, and then use the human cartilage in horses the following year, and then move on to human phase 1. And for the bioreactor protocol, we hope to have a system in place for the 3-liter system later this year. And the vertical wheel bioreactor system is a scalable system. They have bioreactors up to 80 liters, but the protocol you use in the 3-liter system is exactly the same as you would use in a 50 or 80-liter system. So another thing that has become apparent speaking to my first investors who are really coming from the human side of things is that there are so many analog conditions between our domestic animals and humans. And we actually wrote about this already in 2007, and others have then written about it in 15, 19, and there are now these subiquity events going on at leading human institutions, recognizing that there is a lot to be learned from veterinary medicine and animals. So what this leads to is that it could be a win-win where, you know, there's nothing, it's extremely costly to have a phase 3 human clinical trial fail. It costs a lot of money. So if you could test your product in other animal models before you move on to those very expensive trials. It would give you added confidence that it would be a good thing to move on, or you would potentially fail faster and then save money. You can also potentially make money faster. There are examples where they went into veterinary patients first, and it actually sped up their human product approval. So they got to market faster. And there's also the possibility that they can use this preclinical human data to get approval for veterinary products. So I think that is really an opportunity, not just for EQCell, but for where we are at the moment at the University of Guelph. So we have been able to establish a number of partnerships that I won't go into detail about here, but they are all extremely well recognized partnerships that are seeing the value in the approach that EQCell has taken in this interface of veterinary and human medicine. So I'd just like to end by pass on my thank you to the Alliance. It has been critical for us to be able to do live animal studies. It has been critical to my career as a young investigator to have these local opportunities, and it continues to be critical even now as a more established PI. And I would say that the Griffin Laird has been critical to EQCell, both with the market assessment and the product development, but very much also in the mentorship and business verbiage and the network that it has exposed me to. And just like Michelle said also, there's been a lot of HQP training going on over the last 10 years to get us to where we are, and it continues to happen. So yeah, like George and Richard said, and others have said, maybe if I were to come with any suggestion, it's maybe just to broaden the call or the viewpoint of what's possible with Alliance funding. And I really think there are some great opportunities in the biomedical health space, and a lot of colleges at the university is talking about One Health, translational medicine, or ubiquity, but it may not be completely reflected in the current calls and priorities. So thank you for your time.
Excellent. Thank you so much, Thomas. So I'm looking at the chat, and I think we end at the time, and I think we have time for one question, and we've got one question that has come in. So I invite anyone, if you have any other questions, please feel free to submit them, and we will run them past Thomas afterwards. But to wrap us up here, question from Rebecca, same as we asked Dr. Oliver, what piece of advice would you offer to other researchers interested in developing a product for market?
I mean, I think talking to investors, I mean, it's a myth that entrepreneurs are young university dropouts and so on. I mean, I think most successful entrepreneurs are actually quite older and come from the industry with experience. So I think there's a lot of support through the Research Innovation Office and also fellow faculties. Of if anybody has an interest in this, I think they should just reach out and definitely do it. And then, yeah, it's just grit and determination, and not be discouraged, and just keep moving forward. Obviously, listen to the advice, but I think there's lots of opportunities and there's lots of support. So I think if anybody wants to do it, it's just a matter of starting the process.
That's wonderful. Thank you so much. Thank you so much for answering the question. Thank you so much for presenting. And so that is it for our presenters. And I'm going to turn us over in just 1 second to David Hobson, the manager of technology transfer and entrepreneurship at the Research Innovation Office, to close us out with some, like I said, insightful thoughts. But before I do just want to thank all of our presenters for taking the time out of their day to join us here early for the duration of this event to talk about their work. I'd also really like to thank OMAPRA for their support in helping put this event together, in particular Tegan Hunt, as well as Dana McCauley and Dave Hobson at Rio. Your help has really been invaluable. And so with that, David, I'm going to turn it over to you to quickly close us out with some final thoughts.
Okay, I think I'm sharing there, am I?
You sure are.
All right, great. All right, I'm going to try and make this quick because we're all busy and we all got next things to move on to, but you can obviously see these slides in the recording as well. But I thought I'd just give you a 10-second overview of the history of Griffin's Lair. So this started in 2014. As many people have said, the goal really was to get research out of the university and into the hands of industry. Why? Because that's where it makes a difference. So I often call this the de-risking program. Make it attractive to industry. We've spent almost $4 million in funding. Projects have various price tags from 15K all the way up to 125,000K. We funded 78 projects so far, so that's a lot. But there still is a lot more that could be done. I want to acknowledge the fact that this was a risky decision and it was originally made by Rich Mokia and Mike Toombs, okay? So these programs did not exist back in 2014 anywhere. So they stuck their necks out to make this happen. And as you've heard, several of the faculty really liked it. A lot of startup companies have been supported by this. There's a list of them there. And we've had over 50 different faculty playing in these projects and trying to make impact. And take a look, 17 faculty have come back for second and third projects. So that's also a testament to the fact that, this is working for very specific projects with a commercial focus. We've had over 60 industry partners. So almost every project has an industry partner, which is key. And it's really hard to calculate jobs, but we estimate that at least 50 jobs have been created by our industry partners because of the work that we've been doing, okay? So back one. Just to summarize, we had 4 of our researchers talking to us about their relationships. And, when George was talking about working with Escarpment Labs, I think, it really demonstrated the value of using rigorous science and a proven screening process, which they developed with this money, to select products with commercial potential. So, I really think that, Escarpment Labs is a science-based company that all started from George's lab. And I want to acknowledge one important thing, that George mentored these founders. George created these graduate students. It's their knowledge that went out into the real world that made a difference. So that is actually the best form of technology transfer. It's the knowledge in the heads of the highly qualified people that we train that go out and they then change the world. So hats off to you, George. Whale and Paul, in my opinion, it's all about the people. You guys have demonstrated that having diverse skill set, different skills complementing each other, having the right values, having shared values, these common values and a shared commitment, a belief that the science will drive the product development and that you really share the risks and the benefits. And so, people are key. Dr. Michelle, Dr. Oliver, I really, you demonstrated the value of doing market research, of knowing what does the world want and not thinking that in the laboratory, because I think that helped you secure follow-on funding. I think it also helped you secure Hitachi, because you had to go and look and seek and listen. And so I think that is key. And then Thomas, you clearly demonstrate the complexity of some of this science and how long and hard it is to get stuff to the market, but the actually demonstrating the technology in the field, in the real world, you call them animal clinical trials, but really that's in the field, can actually move the whole space forward, whether it's for the animal industry or for the human industry. So, you talked about the fact that, fast failures may save you money. Well, you got to get it out in the field to understand the potential of the technology, but also fast successes may totally accelerate the technology, not just in your space, but in other people's space. So all of that, I think, is just excellent. So take-home messages, just to really quickly summarize, the research is important and it's necessary, but it's not sufficient. You need follow-on support for years and years and years to get to market. That you cannot get a quick product to market. It is extremely hard. You need things like the Griffin Layer program to keep supporting it. That's why several of these researchers have come back to get more Griffin Layer funding, because it needs a little more help to get across the finish line. It's people, not the technology, that makes the difference, okay? It's the people, their values, it's their commitment that makes the difference, and they want to move this stuff forward. And so always remember that. You cannot just throw money at a technology and make it work. The other thing is that product development is a long process, and it's not rigid. This is not a plan that you stick to. This is a flexible process. You have to get ready to pivot, because you are pivoting to the opportunity in the real world, and the real world is not fixed. And lastly, I would say that more interaction and more feedback from industry creates more impact for everyone. So the more we can get the relationships working together, very strong, very interactive, very little friction, the more we are going to benefit. Okay, so next, I want to do a little commercial, which is the Griffin's Lair finale is coming up next week. And so I want everybody to know that we have a different program this year. Because everybody's online, what we're going to be doing is we're going to be having a week of very interesting showcase videos and interviews and pitches. And that's going to be the Research Innovation Festival. So from Monday, May 10th to Friday, May 15th, tune in every day. There's going to be snippets that you can tap into, or you can watch them as they're after they're recorded. But this is going to kind of give you a daily flow of information. At the end of that week, okay, on Friday afternoon, we're going to open up the People's Choice Awards so you can vote. And you'll be able to have seen all those 5 teams pitching during the Research Innovation Week. And then you can vote for the one that you think is best, and they may win a $2,500 prize. And then lastly, the following week on Wednesday, May 19th at 1 p.m., make sure you tune in for the finale, the final pitch competition, the winners, and a few important interviews. And we'll see who wins the grand finale of $10,000. So please prepare to tune in. If you haven't already registered, then please go to Eventbrite and just do a search for 2021 Griffin's Lair and register. And that's how I want to end out. And Shannon may have some final questions, but they're going to send you a survey. And if you have questions, there's an email here. And over to you, Shannon.
Thank you so much, David. Thank you, everyone, for attending. I don't have any final questions. I have a final request that we will be sending out a survey, so please fill that out. It means so much to us. We will also have a recording of the event available shortly, and the slides for the presenters will also be available to share. So please check out our event website, which you will receive in an email afterwards to follow up. And please check out the Research Innovation Festival. It's going to be incredible. It is hotly anticipated, and I think it's going to be really great. That is it for us. Thank you, everyone, for giving us 2 and a bit hours of your morning. I hope everyone has a wonderful rest of your day. And we hope to see you again in person shortly at another one of these events. Have a wonderful day, everyone.